Unraveling the mystery of logarithmic equations. Hello, and welcome to our English language learning channel. Today, we're diving into an exciting mathematical concept, logarithmic equations. If you've ever wondered about these intriguing expressions and how they work, you're in the right place. We're going to break down everything step by step, making it as simple as possible. Let's embark on this mathematical journey together and demystify logarithmic equations. Before we tackle logarithmic equations, let's understand what a logarithm is. In simple terms, a logarithm answers the question, to what power must a certain number, known as the base, be raised to produce another number? For instance, if we have 23 equals 82 cubed equals 823 equals 8, the logarithm asks, what power should 2 be raised to get 8? The answer is 3. This is written as log base 2 of 8 equals 3, or in mathematical notation, log underscore 2, 8, equals 3. A logarithmic equation is an equation that involves a logarithm with an unknown variable. These equations can often be solved by applying the properties of logarithms, converting them to exponential form, or using logarithmic identities. The key to solving a logarithmic equation is to isolate the logarithmic part and then rewrite the equation in a form that makes it easier to solve. Solving logarithmic equations typically involves a few steps. 1. Simplify the equation using logarithmic properties if necessary. 2. Isolate the logarithm on one side of the equation. 3. Convert the logarithmic equation to its exponential form. This is crucial because it transforms the equation into a more familiar form, making it easier to solve. 4. Solve for the variable in the exponential equation. 5. Check your answers. It's important to substitute your solutions back into the original equation to ensure they are valid, as some solutions may not satisfy the initial logarithmic equation. Let's go through an example together. Suppose we have the equation log underscore 3, x, equals 4. To solve for x, we convert this to its exponential form. 34 equals x3 to the power of 4 equals x34 equals x. Therefore, x equals 81, x equals 81, x equals 81. This process shows how we can find the value of x that makes our original logarithmic equation true. Congratulations on taking this step to better understand logarithmic equations. We hope this video has illuminated this topic and made it more accessible. Mathematics is a language of its own, and by breaking it down piece by piece, we can all learn to speak it a little better. Thank you for joining us, and we look forward to exploring more fascinating topics together. Keep practicing, and see you in our next video.